Hello everyone. With the topic of lists, we'll be moving on to part 2 of this course. Part 1 of the course covered the concept of control flow. Control flow is all about which particular line of the program am I currently executing and which line of the program will I be executing next and so on. Part 2 is going to cover the concept of state. State is all about how do you organize your data in an efficient way in order to be able to analyze it. We are going to discuss a lot about data structures. List is the first example of a data structure. Let me motivate the need for lists. Let's go back to the Battleship program that we wrote code for a few weeks back. Recall that the user is allowed to enter guess for X and Y location where they want to check whether a particular ship is placed within the grid. Let's say that we have a 10 cross 10 grid. If I ask you to keep track of every possible user guess location, how many variables do you need for that? That would be 200, correct? That's because to keep track of one user guess, you need to store the X position and the Y position, and the user can guess anywhere within the 10 cross 10 grid. 200 variables is way too much for anyone to be able to handle within a single program. Everyone will go crazy. This part of the course is going to be about handling more and more data with fewer and fewer variables. Let me outline the learning objectives for today's lecture. List is the second type of sequence that we'll be covering in CS220. So we are going to compare and contrast list sequence and string sequence in order to be able to understand the similarities and differences between them. Then we are going to cover an important topic of mutation. Finally, we'll be learning how to switch between strings and lists using two method calls of split and join. The reading for this particular material is chapter 10 of Downey book. Please make sure to go through that. We are going to get started by doing a quick recap of the concepts of indexing, slicing, and for loop using string sequence as an example. Recall that a string is nothing but a sequence of characters. Indexing enables you to get one specific item from a given sequence. For a string, that's going to be a single character. Let's say that I'm initializing a variable MSG with the string value of hi world exclamation point. How can I do indexing? I'll have to say MSG open square bracket index position close square bracket. We read this particular line of code as MSG of 1. What is MSG of 1 going to retrieve us? That's going to be the character I, correct? That's because index position starts at 0 always in Python. MSG of 3 is going to get the character W. That's because we do assign a specific index position for the space character. What does slicing enable us to do? Slicing enables us to retrieve a set of items within the sequence. In case of a string, we are going to be able to get few characters out of the string sequence when we perform slicing. The syntax for slicing is very similar to indexing. Within the square brackets, you'll be mentioning start of a slice, then colon, then end of a slice. Both the start and end are going to be index positions. Recall that the start is inclusive and the end is exclusive. What do I mean by that? You will be taking the character at the start index position for your slice, but you leave out the character at the end position for your slice. So what will MSG of 3 colon give me? That's going to retrieve all the characters from index position 3 up until the end. Since we did not mention any end here, Python is going to retrieve all the characters as part of this particular sequence from the index position 3. That's going to be world exclamation point. How do we use negative values for indices? -1 is going to be the index for the last item in your sequence, which is going to be the exclamation point in this particular string sequence. Since end is exclusive, MSG of 3 colon minus 1 is simply going to retrieve world here. What does for loop enable us to do? For loop enables us to step through every item within your sequence. That's going to be every character within the string sequence over here. Your for loop syntax is going to be for some variable in some other variable colon. The first variable is going to be a brand new variable into which you want to assign every individual item from your sequence, and the second variable is going to be the variable name which is storing your sequence. That's going to be MSG in this particular example. What if we want to store other things within a sequence than just characters? Let's understand the basic syntax for defining a string sequence. You'll be mentioning start of a quotation and end of a quotation. Within the quotation, you'll be typing out the sequence of characters. So Python will understand that you're defining a string sequence by watching out for the quotations. Of course, you can either use a single quotation or a double quotation for defining a string. Let's look at the syntax for creating or defining a list. You'll have to type out open square bracket and close square bracket. Within the square brackets, you'll be using comma separated values. So lists can be used to store different things like integers, floating point values, strings, booleans, or any sort of combinations of those. In this particular example, we are defining a list into a variable called nums, and we are storing three integer values of 22, 11, and 33 here. Let's go through examples of indexing, slicing, and for loop for this list sequence. Nums of 0 is going to retrieve the item 22 here. Nums of minus 1 is going to retrieve the item 33. Recall that whenever you use a variable for a string sequence, you can always replace that variable with a string literal. Similarly, you can replace the variable for a list sequence with the definition for the list itself. The problem with this particular example is that there are too many square brackets, which can be confusing. The term for that is called as overloading. We are overloading the meaning of square brackets, and it has multiple meanings. The first set of square brackets is for defining a list, and the next set of square brackets is for indexing. Of course, we already know another use case for square brackets, which is slicing, correct? So how does Python differentiate between all of these usages of square brackets? You need to look within the square brackets. If you have a comma, then you're defining a list. If you have a colon, then you're slicing. If you neither have a comma nor a colon, then you're indexing. In a similar way, you can identify that the first square brackets here is defining a list, and the second square brackets here is indexing. And this is going to retrieve the value item 11 here. That's because we are looking for index position 1 within this particular list, which is going to be 11 here. Let's talk about slicing. Whenever you slice a particular sequence, you're going to get a subsequence of the same type. If you slice a string, you're going to get a string. So if you slice a list, you're going to get another list. So we are extracting the slice of nums of 1 colon here. That's going to get all the items from index position 1 up until the end, which is going to be a list which contains 11 and 33 here. What is slice of nums of 3 colon? That's going to be an empty list. Recall that Python is fine if you use a non-existing index for slicing, but for indexing, you need to always make sure to only use existing index positions. Python is flexible when it comes to slicing. Let's go through an example for loop. Similar to the previous example, we are going to say for x in nums and print of x. That's going to display every item within the nums list over here. Let's go through a simple example where we define a list of numbers and we want to be able to add all of those numbers together. I'm going to switch to Python tutor. Let me define the list as nums here, and I'm going to type in open square bracket, close square bracket. Let's use 2, 4, 6 as the items within the list nums. Let's look at the visualization on the right side here. For lists, unlike other variables, you're going to see an arrow representation. Eventually, we are going to learn what are objects, and you'll understand this particular arrow representation here. And the arrow is going to point to a list of items here. Observe that Python tutor is listing the positive index positions on the top left corner. It's nice in that way. For the negative ones, you'll have to write those out on your own. What we want to be able to do is to compute the sum of all of these numbers, correct? So let me iterate through each of those items by using a for loop. So I'm going to say for cur underscore num in nums, and let me just for now print cur underscore num. It's always a good idea to test your for loop by using a print function call initially. Looks like we are getting each of those numbers out. In order to be able to compute the total, I need to define a variable outside my for loop. So I'm going to define a variable total and initialize that to a value of 0. Recall that sum is a keyword in Python, so you're not supposed to use that. So I'm using the variable name as total instead. In order to compute the sum, I'm simply going to add up total with the current number. I'm using the syntactic sugar shortcut. This is the equivalent of saying total equal to total plus cur underscore num here. Let's step through this particular program from the beginning. We initialize a global variable nums with a list and another global variable total with 0. First iteration of the for loop is going to get the number 2 out and store it into the variable cur underscore num. Then we are adding up total's existing value with cur underscore num. So total is now going to become 2. And when we add up total for the next iteration with cur underscore num, that's going to add 4 to the value of 2, which is going to now get updated to 6. The next iteration of the for loop is going to update cur underscore num to item 6. So total is now going to get updated to a value of 12. And observe that you will go back one more time to verify that there are no more numbers to retrieve from the sequence of items here, which is represented using the list. Let me switch back to the slide deck, and we are going to talk about other sequence capabilities. There are other things which you can do in general with any kind of sequence. Those are going to be length, concatenation, in, and multiply by an integer. Let's go through examples for each of those. I've split the screen into two. The left side part is an example for a string sequence, and the right side part is an example for a list sequence. I've defined a variable MSG with a string 321 go. On the right side, we have a list variable items, which is initialized with a list of 4 items: 99, 11, 77, and 55. Recall that the len function enables you to count the number of items within any kind of sequence. So len of message is going to be 5 because we have 5 characters, and len of items is going to be 4 because we have 4 items within that list. Let's talk about concatenation. Recall that the plus operator enables you to concatenate two string sequences together. When you concatenate MSG with triple exclamation point, you're going to get a brand new string which contains the value as 321 go 3 exclamation points. Similarly, you can concatenate one list sequence with another list sequence. That's just going to take the items in the second list sequence, and it's going to join both of those together to produce a brand new list which contains all of the items from both of the list sequences. Let's move on to talking about the N operator. We have already covered one use case for the N operator. That's as part of your for loop syntax, correct? You're saying for variable name in your sequence variable name. That particular use case of the N operator enables you to retrieve every single value within the sequence. Another use case for N operator would be for you to search for a particular value within a given sequence. Let's say that you're searching for the character G in MSG. You're going to get a Boolean value of true. That's because G is part of MSG. Similarly, 11 in items is going to retrieve a value of true. If you search for Z in message, that's going to give you a Boolean value of false. Similarly, 10 in items is going to give you a value of false. This is going to be very handy when you want to search for something excuse me, within your sequence. Let's talk about the last operation here, which is multiplication by an integer. Please pay close attention here because this is going to be a different behavior than you might expect when it comes to list sequence. When you multiply a string sequence by an integer, you're simply going to replicate the string sequence that many number of times as provided in the integer, correct? Similarly, when you multiply a list sequence by an integer, you're going to replicate the items in that list that many number of times. This is going to be very different from what you've learned in vector algebra. When you say items into 2 in vector algebra, that means that you're going to multiply every item by the value of 2. Python is going to behave very differently. You can remember what will happen when you multiply a list sequence by an integer by remembering that when you multiply a string sequence by an integer, you replicate that string, because it doesn't make any sense for you to multiply each of the characters in the string by that particular value. So keep in mind that multiplying a list sequence by an integer will replicate the list sequence by that many number of times, and you're going to get a brand new list sequence, just like you get a brand new string sequence out of the string operation here. I'll wrap up this video here. In the next video, we are going to talk about the differences between strings and lists.